Hi, welcome back. Today we're going to clean the chassis and maybe do a bit more work. The first thing I want to do is actually cut off the plug. The plug is actually fine. It's actually in decent shape and could be usable, but unfortunately because it doesn't have the ground prong in the United States here, we have plugs that require, newer plugs that require one of the sides being hot neutral, and it has a special ground prong to it. So I am going to just cut this off, and as I mentioned in a prior video, I like to save the old plugs for maybe using for the future for something. I'll figure it out. And this goes in the garbage. Normally what I'd like to do is take off this whole top piece because it's really dirty, and I'd like to repaint it as well. But the problem is all the connections from up here to down here are riveted, meaning I would have to drill them out and then re-rivet to put them back in or use screws. So I'll work around that. I don't want to take that apart too much. But let's take off the back, see if we can get the antenna off to allow ourselves some more room for cleaning. It's interesting, even though this is 1940 radio, it has a phono plug, which means if you have something external, like a record player or phonograph as they called them back then, you'd be able to use this, use the speaker from here to actually amplify and play the sound. So, good. Okay, these actually took the screws out. These have little spacers to separate the antenna from the chassis. And let's look at what we have here. Alright, I want to take this off. I don't like the look of it. The wires are back here seem to be a little frayed and need to be reconnected, so I'm going to disconnect them. But let me figure out the best way to do that. Put something under here to keep it steady. Move that up a little. Now I can use the schematic to determine what wires goes where, but I think in this case I am just going to label them one at a time as I take them. So I'm actually going to draw myself a little diagram and get that set up, and I'll show you what I do in a moment. I'll be right back. Okay, I am back. What I've done is I've just kind of drawn the radio back here with the different connections, and the other side of the radio where they point to. And I'll verify those against the schematic off camera, but it seems to be fairly straightforward. So now we can just cut the wires at the back of the antenna. They are really frayed. Wow. Okay. Good, and now you can see this is what the back of the antenna looks like. On this side you see the phono plug that comes into here. It's connected there. We have a little resistor here. Looks to be in good shape, but we'll measure that later. Secondary coil, and then the main antenna coil. And this item here is simply the, if you have an external antenna, you can hook that up as well. Let's put that to the side and take a look at the chassis again. All right. I'm taking off the light bulb to get that out of the way so I can clean it. The bulb actually seems to be, yeah, I can see the filament and it looks fine, but I will test that. But generally I replace those automatically anyway. Should be number 47. Oh, it's a 44 actually, so I have to check against the schematic to see if one of them had a number 47. That really just makes more of a difference in the voltage. I don't know what the 44 is for that. And this is coming a little loose, so I'll tape that up as well, some electrical tape. Alright, now I want to clean the top side of the chassis. I'm not that interested in getting all the rust off and things like that. I mean, these are older radios. I just want to try and get some of the grease and grime off. So let me prepare that. And I'll show you what I do. I'll set it up and I'll be back in a moment. Okay, I am back. What I'm doing now is I'm taking these little felt pads. You've probably seen these in the bottom of chairs. People put the bottom of chair feet, legs, to stop scratching. But they almost the perfect size to protect the tube connection, because if you're spraying anything or cleaning anything with any kind of chemical or even water, you don't want anything to go down those particular holes and theoretically affect a tube. This particular chassis does have a lot of other holes on it, as you can see, so I'm not actually going to spray anything. I'm going to put something on a cloth and clean it with that, but this would go right down to the tube sockets, and who knows what it would do to those connections. One more. Good. So I have something called Super Clean, which is a dissolver and greaser. So I'm going to spray it onto paper towel and we'll see what it looks like on that. It's very foamy. I'm actually going to put it in the area right here first. And you can see it's doing a good job of getting the grease off already in some spots with the dirt as well. I'll also be cleaning off the top of these things. Got to be very careful with the transformers. You do not want anything going in. Oh, it's interesting. I just spilt a little over here and I see it did a good job of cleaning that as well. So I'll use that also. So I'll finish this off camera and kind of show you the results. Don't expect miracles. Just expect it to be back. I cleaned as best I could. There is some rust on it, but it doesn't matter. It's the inside of the radio. I don't really care what the inside looks like. I know there are some people who are very particular about that. A prior radio I'm working on, or I worked on, it's all ready. I'm just waiting for the weather to cool off so I can paint the cabinet. The chassis was in pretty rough shape, and I decided to clean that and actually repaint that, and I'll show you that right now. So this is one that I've done and I've repainted. You can see everything's clean, and the chassis is nice and shiny. I also repainted the top of that, which is nice as well. But for the particular radio I'm working on now, the 1940, I'm not going to bother doing that. So the next step, I am actually going to start replacing the capacitors. I'm going to set up for that, and I will show you some of that. I don't want you to be too bored, so I'm not going to show you every single capacitor being replaced, but I'll show you a couple, and then the final view once that particular aspect of the project is done. Okay, welcome back. I've been doing a comparison of the chassis to the parts list here. have the capacitors highlighted in yellow. And to the schematic where I can find them. The interesting thing is there are too many differences. So this one's going to be a play it by ear. When I look at the actual chassis itself, I can see that we have 1, 2, 3, 4, 5, 6 wax capacitors, which does match up to the parts list. The originals, I can tell, are very old. That's 1, 2, 3. There's one under here, 4. These two are the replacements, and they actually match up. I'm sorry, that matches up. This one does not match up. This is saying it's 0.005, but when I look at the schematic, it is telling me it's 0.05. So a little difference there, but I'm going to review that later. So before I actually start doing the cleanup, I just want to get rid of some of these wires that we're not going to be using anymore. I mentioned that I will put a new dial cord in. The one thing I'm trying to decide is, because it is an older radio, and not that it's really valuable, but it's probably worth a little bit more than the new RCAs. Rather than painting it fancy colors, I'll just strip it and paint it the original colors best I can match, which means I have to find an ivory cord. I have black cords, I have white cords, I have brown cords, so I have to get a hold of an ivory cord. I'll order that. I'm just going to cut it off there. I know that's not, looks like I'm not just cutting things, but I know where they go because I've done enough of these. And I'll clean up the connections when I actually redo those. Okay, good. The other thing I want to get rid of is, because I do have to replace this electrolytic capacitor, which isn't original also, by the way. I can check out what that's from. I'm going to guess sometime in the late 50s, early 60s, but once I take it out, I can look at the number to see. And what I generally do is, the wires are actually very good, so I'm just going to cut it here. And I can move the wires out of the way then to work. And we have the negative wire as well, which is here. Good. They have this, looks like this was added later on. I can tell by the soldering. And we actually don't need that here. So I am just going to cut this one away as well, but need something a little sharper. Sorry if my hands are getting in the way. Be careful I'm not cutting any wires, and I'm just cutting this. Good. Got that out. Now let's see what we can learn about it. Okay, it's made by Sprague, which is one of the bigger companies that used to make these. But let me see if I can get this off to read more. It's a 50 and a 30 MFD with 150 volts. And that's exactly what the schematic calls for. So this likes to be proper. Looking for dates of manufacture, which I don't see. It does have a number 317, and that may mean something to the manufacturing, but usually there's some sort of date codes that you can figure out. Not for this one though. But I'll be replacing those with new parts. Okay, so I will start to do the different ones here. I'll start on the right side here. This is filthy. This is a 0.05, which is a very common one. And they really don't make 0.05s anymore, but they make 0.047, which is close enough. These really don't have to be exact. Close enough is good enough in this case. This is interesting. It was wrapped around. Okay. So all these extra leads on here. I guess they never cut off the original one, and I'm simply going to add the new one onto here. You know, as a matter of fact, there's a lot of... I'm just going to cut that part off because there's so much solder. This will have a fresh connection right to that. This was set up for here, so I'm going to do it the same way here with the foil side. Some of the capacitors, the American made ones, still do the foil. So I'm just going to clean that up. Do a J-hook connection here. And that fell off. Perfect. Okay, I think I'm going to clean this particular connection up. There's so many loose settings there. Okay. There we go, we'll do it that way. Get my solder. Good. To the other side. Okay, the first one's set. Move on to the next one. 0.035. I keep all my items in a spice jar, and I have a whole inventory of these. I don't have 0.035. I have 0.033, which again is close enough. And you can't tell on the foil side here because there's really nothing on here. So what I'll do is I'll just cut it off here, cut it off here. These are actually, these particular capacitors I've never really worked with before, ones that are that old. I don't bother checking to see if they're good, it's just assume they're bad, but some certainly could be good. But so I will just do the labeling the same way, just to see if it makes a difference. Because this has a long lead, I kind of want to put a protector on it to avoid any unnecessary interference, and I'll do that to both sides. This is just installation. And this way you don't have to worry not only about the interference, but also should there be any wires touching, that'll protect it as well. I'm just trying to get a ballpark for that. J-hook it. I'm going to add a little protector on here as well. It's hard to keep talking as I'm focusing, so apologies for that. Okay, all set. It's good. And I'm going to give this a little extra room here, because if you notice on this side, this is loose, and that's because this has to sit down for the tuning condenser that we cleaned, and once I put it back, so I want to make sure there's plenty of room of give. Could use a little bit more. That one. Make that a little longer. Okay. Okay, that one's all done. I'm going to work through the rest of them, and I'm not going to film those because, as I mentioned, that'll be kind of boring, but I'll show you the results once we come back. We'll also then replace the electrolytic capacitors, and we will test the resistors. Be back shortly. Hi, welcome back. I just wanted to share something I found as I was working on this particular capacitor. Firstly, it's connected to the, it's the red coming out of the second IF transformer. And it kind of wraps around here. And it's probably difficult to see, but you can see it comes through here. This is all bare. This is supposed to be covered with rubber wire. And for some reason, more than any other color in the older days, red seems to be the one that flakes the most. So I could run a new wire. I'd have to take apart the IF transformer, which is something I don't want to do. But what I'll do instead is I will, the stuff that's flaking off, I'll get rid of that, and I'll put something over to protect it. What I also noticed is it was hanging free, and there's on the power switch, there's a little control here, and looking at the schematic, this is where that should be connecting to as well. And you can see it looks like they did something and just didn't really do a good job on that. So I will have to reconnect that as well. And I just wanted to share some of the problems you can come across as you're working on these radios. Be back again. Thank you. Okay, welcome back. So the challenges continue. As I was trying to do the rest of the capacitors, and I was going to put a covering over that red lead, I found that the actual wiring, the rubber wiring on the red lead, was bad all the way through. So you can see here, there's bare wire. This would have been touching against here, it would not have worked. So I'm basically going to redo the red wire here. And as I have this open, I notice that the green one is not too healthy either. Red and green, both of the colors that seem to have the problem. And I will be replacing this wire as well. There's really no need to show you that. I can show you the finished product. It's simply just a matter of unsoldering and resoldering new wires, and I'll get that prepared. Always something. Hi, welcome back. So I completed the wiring. I replaced the red wiring here and the green wiring here. The coils are very, very sensitive, so what you have to make sure you do is that you're not ripping other pieces of wire. And to show you what I mean, you can see these very, very thin wires that make these connections. If you ruin those, you're in trouble, and you need a new coil. So since I replaced the wire, I just wanted to test to make sure I'm getting what I got early when I did my tests. It was, it calls for 16 ohms. I think I got 17.2 when I did the initial tests. This side I didn't touch, so that should remain the same. And that is, I'm getting 18 or so here. And this side I'm getting 17.2 what I got before. So far I haven't broken anything after I replaced the wires. I'm going to put everything back together and we'll see. We'll measure from the bottom to make sure that still works as well. I'll be back. Hi, welcome back. Okay, I did quite a few things here that I wanted to share, and I'll point them out and we'll move on to the next step. First of all, I replaced all the capacitors, the electrolytic and the paper wax capacitors, so you can see the ones in yellow here. Interesting thing here, if you recall earlier, I was mentioning that there was one capacitor that was not matching up. It said 0003 and 005. It turns out this is a dual capacitor, and I've actually never seen this before. So it's one capacitor that's both 0005 MFD and 0003 MFD, and they combined it into one, and that's why I was having trouble with that. And that is over here at the end, and I have those hooked up. There's one capacitor I haven't replaced yet. It's this one. I want to look into it a little more before I do it, because I want to make sure it's not a certain type. It's not saying so on the schematic, but I'm not used to seeing these in older radios, so it could be a replacement as well, but I'll look into that. Wires. I had to replace so many wires because of the fraying. I replaced the one going out to tuning capacitor over here. I replaced, as I mentioned earlier, the one of the greens, one of the grounds on the one of the AF transformers. I'm sorry, IF transformers, and I replaced two, which is underneath here, which was a pain because I had to take this out. This is the trying to think of the right name for it. This is the choke for the speaker coil. So I had to replace the red wire, which right on the IF transformer, that went over to here, and the green wire, which is a ground, that went over to here. So I replaced all those as well. I hooked back up the tuning capacitor. I reran that wire and the one on the bottom as well. So what I wanted to show you before I moved on is what a mess this made. So let me just move stuff out of the way for a second, and you'd really be amazed at all the stuff that came out of this radio. Look at all this stuff. I mean, besides the condensers, all the garbage that came on, all this stuff, it's wire and frayed rubber, and of course these guys, but it really is disgusting what's inside a radio. Alright, so I'm going to set up now to test the resistors. Welcome back. We'll be right. We're ready to check the resistors. I did a comparison from the schematic to the parts list, and I'm happy to say we have the right number of resistors and the right amount, so I can find them between the parts list and the schematic. So here we have 1, 2, 3, 4, 5, 6, 7, 8. And when I look at the schematic, I highlighted them in red. 1, 2, 3, 4, 5, 6, 7, 8. So that's good. So now we'll actually just do the testing of the resistors. Every resistor has a color code on them, and there's a horrible expression to remember the color and the combination, so I'm not going to use it. I simply use modern technology and use my iPhone, and I'm able to determine what the resistance should be. So if I'm looking at the one over here, and that looks like brown, orange, I'm sorry, I'm going from the wrong side, red, red, orange. So I plug into my phone, red, 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 orange. That should be 22K. 22K is indeed a resistor we should have, 22,000. So now I will just test that just by putting these little clips on each side. Now I'm going to put this up here so you can see it. That's coming out as 28K, so it's a little high. Now the truth is, most of these can be off. It's either a 5, 10, or 20% tolerance. So this one's probably fine. But if I have other ones like this, I may end up changing them. So I'll just make a note on the parts list and what it's registering, and make a determination later if I want to change it. Okay, I will move on to the next one. Okay, this is one under here. It's hard to see. and that one is orange, orange, green. So looking here, orange, orange, green, that should be 3.3 meg. It's measuring at almost 4 meg. So that's about 30%, almost 30, I'm sorry, if I do the math right, that's about 20% off. It's probably fine, but I may end up changing that as well. I'll decide. Just make a note, 3.9 meg. I'll move on with the next one. One thing that you may notice if we're way off on a number, if there's something, a resistor that's also in line with another resistor, that can be an issue, because it'll throw off what you're measuring, because there's a resistance from one of the other components. So generally you can disconnect one side if you need to do that. Okay, we're going to look at this next one. This is yellow, violet, and green. Yellow, violet, and green. Should be 4.7 meg, which is proper. And let's see what's coming up here. 5.5. So all of these seem to be a bit high. So I have a feeling I'm going to be replacing most of them, which is something I normally don't do. Resistors usually stay very, very accurate over time. They may drift a little, but being that maybe because this radio is 80 years old, some of these have gone out of tolerance and drifted a little too high. Next one over here, that's brown, red, brown. And this one says brown, red, brown. It ends in silver. And I'll show you what that means on here. So brown, red, brown. I hit silver. And that means that's good for 10%. So generally you're good within 20% of tolerance, unless it has one of these other colors, of 5% or 10%. So this is just 120 ohms, which is what is expected according to the schematic and the parts list. And this is 289, so that one is way out of tolerance as well. Uh, 289, that's way out of tolerance. Let me make sure I have that reading right. That's red, 220, yeah, 220 and 289. I'm sorry, I'm trying to make sure I did something right here. Brown, red, brown. Oh, I had it backwards. Brown, red, brown. 120, and it's 289. Okay. Moving on to the next one. This one here is yellow, violet, yellow. Which is 470K. Let's see what we get here. This, if you notice here, there it's dropping down. Okay. Once it goes over half a meg, sometimes it moves this from K to M for meg. So this should be 470. It's 552. That's actually within tolerance, but I will probably change that as well. Resistors are very inexpensive. There's another one underneath this thing here. It's red, red. This one's going to be a little harder to get to. There's also some dressing on it. Okay, red, red, yellow. Red, red, yellow. Sorry, red, red, yellow should be 220. $220K, which I do see one up there for that, and it is reading 289. So again, drifted higher. So we will probably change that one. The next one I'll just leave up here. This one, it's very dirty or it's burnt. And this is in the power trend, the output tube, which is the most voltage in a tube, so it wouldn't be surprised if this one's bad. This looks like brown, red, red, silver. Brown, red, red, silver. That should be 1.2. I just want to check that on the schematic to make sure that's right. 50. I'm actually not seeing that right now. Brown, unless it's just so dirty. Oh, it's brown, red, red. Brown, red, red, silver. Brown, red, red, silver should be 1.2. Oh, I found it, 1.2, and he's reading 1.3, so actually he's not that bad. I can keep him in there if I want. I'm not sure if I'll do it or not. And then the final one is actually on the antenna coil. Okay, this one is orange, orange, red, which I think we had already, another one like that. So orange, orange, red should be 3.3K, which I do see on the schematic and on the parts list. 3.3K. And he's coming out as, let me kind of get him over here a little more, get everything in a picture. That's an unusual number. It could be because there's a coil associated with this and making that number off. I'll replace it anyway. But to show you what I meant earlier about accurate measurements, let me cut him off from here because I will be replacing him. And now you see, once I disconnected, he went to 3 points. So he would have been fine had I left him there, and I actually could connect that again, which I may do. But that's it. So it looks like we're going to have to replace all the resistors, and I will take that on next. Thank you for joining.